There's also another source of tremendous waste heat, which is industrial waste. And the typical thing, you start with an industrial plant, you buy some electricity and some processed fuel, you make some finished goods, and you throw a lot of waste energy off the plant. Once again, same silver bullet. Why don't we go into that plant and build an energy recycling plant to take that heat that's being thrown away, convert it into useful electricity, steam, and hot water? One of my suggestions to the association is to expand much more into the industrial area, because it's the same. A lot of the vendors here in the room are selling into that area because it's the same thing, except you move steam around on one guy's property. All that saved energy output, you do a better job. This is a picture of one of those plants that I've been involved with. It's kind of a large thing. If you look down here in the front, there's some semi-trailers. This is an aerial picture. Chicago's in the background. 268 coke ovens that bake coal to turn it into blast furnace coke. And then all along back there, I don't know if I can get an arrow on here or not, probably. Oh, here it is. You see these little short stacks? Well, the scale of this, there's 16 of those. They're three stories tall, those short stacks. And they're just the bypass stacks, because every 16 of these ovens, the gas comes into a heat recovery steam generator, makes, I don't know, a whole bunch of steam, 1.3, 1.4 million pounds an hour. That all gets scrubbed in that building right there, and then comes over here and makes up to 95 megawatts of electricity and, up to 900,000 pounds of steam. This single plant produces as much clean energy every year as was produced by all the solar photovoltaic collectors that were connected to the grid in the world in 2004. It is such a stunning number that nobody stops to believe it, and yet we say there's no silver bullet. We need to do all these things. We spent $5 billion putting up those solar collectors. This plant cost $165 million, and it saves as much carbon. If you're an investor, where do you want to put your money? $5 billion or $165 million for the same result? Recycling waste energy is very cost effective, and this is what gets very interesting. What we've done here is we've looked at the dollars per megawatt hour to deliver clean generation. So we count the cost of making it, the capital cost, the fuel, the labor, and the wires, and the load factor. We put it all in. This is an article that we've just written. And if you want to put in photovoltaic solar, you need to get a little over $400 a megawatt hour. And in fact, we've got in Europe a 43 cent feed-in tariff. 43 cents is $430 a megawatt hour. If you want to do concentrated solar, presumably you can get it done a little cheaper, and a lot of people are trying to get that 42 cent feed-in tariff for $300 power. Offshore wind, pretty expensive. Now come down, we're staying on the green ones. Onshore wind needs about $200 a megawatt hour when you count the wires and the backup and all the other things, not just the price at the generator. You get down to biomass electric only, it's still not a very good deal. $180 a megawatt hour. Back here, let's just tap one more thing. Whoops, back. Let's put in where the average cost is in the United States. It was about $100 a megawatt hour. So all these things I've been talking about are more money. Geothermal, another recycled energy, still costs more than the average cost. Now look what happens as you get to some of the conventional things that are supposed to be a little cleaner. Integrated coal gasification. That's going to cost you $120. You want to do coal sequestration? There's the joke of the year. It's going to cost you $180 a megawatt hour to do it if it works and if the stuff stays in the ground and if you can afford it. Well, now look at the waste energy recycling. Now, what is the silver bullet? It's very simple. Use energy twice. You got it? That's all you need to know. Use energy twice in your home. Right down here, those 4 technologies that fall below the average cost have one thing in common. They use energy twice. Look what happens to biomass when instead of just making electricity with it, you site it near somebody and run the heat through some pipes. Bingo, you need less than $100. Fossil-fired CHP, you need less than $100. If you can recycle energy and only get electricity out of it, you're down to something like 80 bucks. And then if you've got a plant like the one that I showed you, you know what that plant sells its electricity for that makes electricity? It gets 20 bucks a megawatt hour. And it's enormously profitable. And yet our rules absolutely discourage what's going on. This is the IDEA role to get down into that sweet spot, use energy twice. Only reuse of waste energy will lower the cost of avoiding CO2 emissions. Every other clean energy solution is going to drive the cost of CO2 up. Look at this. If you want photovoltaics, solar, it's the equivalent of paying over $300 a ton for CO2. I got nothing against solar. I got nothing against any clean technology, except why not put our money in the one that pays us the most? Seems logical. Look at what we got to pay if we're going to do coal sequestration. $180 a ton. Look what happens if we use energy twice. We get anywhere from about a $5 a ton savings with biomass, CHP, all the way up to a $50 a ton savings if we put something else up. As a matter of fact, all of the customers we've ever had have reduced CO2 and saved money. We have yet to pick up our first dollar of carbon sales. Hopefully it'll happen, but it hasn't yet. What about government policy? Well, government policy is you go to the racetrack, you look at all the horses that are running, you find out the one that's got 3 legs, lame and everything else, and you pour the money into that one. We're supposed to be a capitalist country. Let me put numbers to this. What we did here, it's very confusing because you hear production tax credits, investment tax credits, all kinds of things, and you can't really put them together. We did. We said, let's look at the installation and figure out the lifetime megawatt hours the installation will make. We actually used 25 years. Now let's look at the total government subsidy that's proposed. In the case of photovoltaic solar, you get 30% tax credit. But what does that mean? It's 30% of $9,000 a kilowatt. It's not 30% of $2,000 a kilowatt. You put it all together, and it turns out that our government will basically give you $54 a megawatt hour for every megawatt hour you make on that. Now, if you do concentrated solar, because it costs less and it runs longer, the subsidy's not as big. It's more down in the 20 range. Offshore wind, still up in the 19. Get to onshore wind, which is where you've got a 20% or a $20 megawatt production tax credit for the first 10 years. Works out to about $10 a megawatt hour for the life of the project. Geothermal, same thing. Biomass, a little bit less because they don't get as much subsidy. Now let's get down to the 4 winners. The ones we've shown you are cheaper. We get a whopping $1.34 a megawatt hour for CHP, and that has been available to us for almost 6 months. In the prior 25 years, zero, de nada, nothing. Now, what about coal? This is where you really understand what Phil said earlier, that there's a lot of energy policies and they're somewhat contradictory. We don't have any production tax credit for coal. We don't have any ITC for coal, but we still have a subsidy. And what it is that we don't require power generators to pay for the environmental damage that they cause. Harvard University did a study, and they found that the average coal in the area they looked at caused $60 per megawatt hour of health and environmental costs, and they didn't count global warming. They counted premature death, infant mortality, pulmonary diseases, emergency room visits, et cetera, as well as damage to our buildings and damage to our forests and so forth. Ontario Medical Association did a big peer-reviewed study, and they found the number was $120 a megawatt hour. The main difference between the two studies was the value they attached to a premature death. So I just simply averaged the two studies, and it looks like the public pays $90 a megawatt hour for every megawatt hour of coal. That's our policy. We pay $54 for solar, we pay $1.34 for using energy twice.